Welcome to the demonstration video of how to use the Target Population Estimation component of the Integrated Health Tool, or IHT, to estimate the impact of a given strategy as represented in the interface of a configured and validated projection file. The impact estimation subcomponent of the tool ensures synchrony between the cost and impact of a given strategy. Let's dive in and explore how to use this component effectively to estimate impact. We have demonstrated how to use the IHT dashboard to configure a projection, typically representing a national strategic plan. During this demonstration, we navigated the different sections of the TP component, namely notification projections, patient-initiated programs, provider-initiated programs, resistance testing and treatment, prevention of TB infections, vaccination and target population summary. We have provided guidance on how to validate the configuration or calibration of an IHT projection in a video on validation, and stressed that it is important that a projection receives review and validation before proceeding to impact estimation, although typically further adjustments follow the impact investigation step. Indeed, an iterative approach is usually followed to prepare a final model. An ambitious strategy is proposed, its budget implication and resulting impact is studied, and then its level of ambition is adjusted until the available budget and the impact targets are maximally aligned. The target population component user will have noticed that several of the sections of the model represent key interventions associated with impact on TB burden. These include TB screening and detection. This intervention can be seen as the overall effect of screening and diagnostic evaluation in all populations at risk of TB disease and from death resulting from TB disease. Finding TB cases early and shortening disease duration will have the most impact. This requires screening in populations at high risk for TB disease who are underserved in most countries with high TB burden. TB prevention. This intervention includes all efforts that expand the prevention-eligible pool and thereby increases prevention initiation for those eligible on prevention. TB treatment outcomes. This intervention includes all activities that reduce loss to follow-up, like drug sensitivity tests and appropriate and timely treatment. It also includes adherence mechanisms and appropriate treatment monitoring elements. Next, we will study these elements in the target population components user interface. We first discuss how the model uses 3 composite indicators to estimate impact, namely 1 detection, 2 prevention, and 3 treatment. We'll go into more detail shortly, and for now mention that there are 2 sub-models that project TB burden. One is a statistical model and one a dynamical model. The statistical model is available for most countries and is the default choice. The user can select the dynamical model option during file creation for a subset of countries. We'll start with describing details of the statistical model. The statistical model projects TB notifications, incidence and mortality from past trends, and regression among the indicators which are obtained from WHO data. Prevalence is estimated from incidence, notifications, and assumptions regarding disease duration. We briefly discuss the statistical model and refer the user to a more detailed presentation available in the Shared Presentations folder. The statistical model does not have any explicit intervention mechanisms. However, we can describe the effect of interventions as influencing transitions between states of the model, namely, the transition of prevalence to notifications in the case of detection, the transition of susceptible to incidence in the case of TB prevention, and the transition of notified to mortality in the case of treatment outcomes. We now navigate to the impact section of the target population model. We can approximate the impact elements described above using the statistical model by defining 3 elements that are part of these state transition. Total cases notified, the reduction in population-level risk for TB disease, adjusted for higher risk in population groups receiving TB preventive treatment, and the treatment success rate for new and recurrent cases, with the last 2 inputs being percentages. These are called hazard rates, borrowing a term from the statistical world. The first 2 values are calculated as aggregates from the user-configured cascade details for all patient and provider-initiated programs, and they are grayed out from editing in the bottom section of the impact editor. Treatment success is a direct input, and it assumed that the costing model includes services and activities that will ensure the stated treatment success target is reached. To estimate the impact of the scenario projection, we need to compare impact-related output indicators between a given scenario projection and a baseline or counterfactual projection. We see that the hazard rate table has two sections for this purpose. The bottom section represents hazard rates for the scenario being configured or modeled. This can be a counterfactual or scale-up scenario, where typically a scale-up scenario represents a TB strategy or a national strategic plan. The upper section represents hazard rates we want to compare to. Typically, this section represents the hazard rates of a baseline scenario. The statistical impact model presentation shows how impact comes from the ratio in the hazard rates of scale-up and baseline projections, as shown in the hazard rate ratio slide of the statistical impact presentation. Next, we discuss how the two files or projections involved are prepared, using two pre-prepared files for demonstration purposes. In the scale-up file, an example strategic scale-up scenario is constructed which begins in 2024, scales up to target coverage 2028, after which coverage is constant to the final year of the projection. The baseline projection must represent base year coverage and continued constant coverage after that. This means going through all the editors of the target population components interface, setting the base year coverage, and then making sure subsequent years continue the base year coverage value. We can also call this projection a constant coverage or a continued coverage projection. Next, we run the model and make a copy of its hazard rates from the bottom section of the impact table to the counterfactual or top section of the baseline file in the impact editor. Since the hazard rates of the upper and lower sections are the same, their ratio will be 1 and no impact is generated for the baseline file. Then the scale-up projection is prepared. To do this, make a copy of the baseline file itself to create a scale-up scenario. A simple way to do this is to simply rename a baseline file after it is saved, giving a scenario-relevant name. Then copy the hazard rates of the baseline projection to the counterfactual section of the scale-up projection. Next, impact is created in the scale-up file. The total notification is increased by setting an overall notification target and configuring the screening and diagnostic sections of all patient groups. TB prevention is increased in provider-initiated populations only by expanding eligibility, which happens by screening and diagnosing more cases and by initiating more treatment-eligible patients on TB prevention. Treatment success is set directly in the impact editor, noting that this input is not explicitly captured in the care cascade, but is assumed to be implicitly captured by increasing drug sensitivity tests, appropriate and timely regimen allocation and costed adherence mechanisms. Since the hazard rates of the upper and lower sections are not the same in this file, their ratio will not be 1 and impact is generated for the scale-up file. We next look at the impact that is calculated for a prepared model. This projection or scenario can represent a national strategic plan, and its impact editor has been configured following the approach we just outlined. We see impact for the following 3 impact indicators. Notification, showing total TB notification for baseline scale-up and the difference between scale-up and baseline. Incidence, showing total TB incidents or new cases for baseline scale-up and the difference between baseline and scale-up. And mortality, showing total TB mortality or new cases for baseline in scale-up and the difference between baseline and scale-up. Note that TB prevalence is not shown here, as it is not reported in the WHO TB burden database. Impact as given by the bottom row is the difference between the baseline and scale-up scenarios. These impact estimates can be summarized and reported for different purposes in the National Strategic Plan preparation process.